Hello everyone and welcome to Del Monte on Science. I'm Lou Del Monte, and we were discussing the relationship between time, existence, and energy. This is part 2. I'd also just like to mention that I'm taking this material from my new book, Unraveling the Universe's Mysteries, which is available at Amazon and Barnes & Noble online. So please, if you'd like to go further, avail yourself of a copy. In the last posting, in part 1, we talked about a number of questions that philosophers have been asking and scientists have been asking for well over, the philosophers for well over several thousand years, the scientists for well over hundreds of years. The philosophers have debated the nature of time roughly for the last 2,500 years, and they've come out with 3 schools of thought. There's 3 separate schools of thought as to what is time. And the first school is called the presentists. That's spelled P-R-E rather, S-E-N-T-I-S-T-S, presentists. And the presentist theory of time is that they argue that the present objects and experiences are real, but the past and the future don't exist. So only the present is real. And in theory, basically they're saying our mind remembers a past and our mind anticipates a future, but none of those actually exist anymore. The past doesn't exist anymore. The future has yet to exist. Only the present is real. So if you were in this school of thought, it actually renders the whole concept of time travel meaningless because you have nowhere to go. They're not real. Then there's the growing universe school of thought. Now, the growing universe argue that the past is real, it actually occurred. The present is real, it's happening now, but the future is yet to happen, so it's not real. So that's the growing universe, the idea that it's going to continue to grow. And so in this school of thought, the only time travel that would make sense is time travel to the past, because that's the only thing they consider real. And then the last school of thought, which is the school of thought that I ascribe to, is the eternalism. And that's the eternalism theory of time. And they believe that there are no significant differences among the present, past, and future because the differences are subjective. And I'm going to actually show you that that is truly the case. And scientifically, when you look at Einstein's general theory of relativity and the solutions that have been found regarding time travel, and you take some very simple examples, which I will do, this school of thought appears to be the solid scientific school of thought, the one that we can actually rest our hat on and work with. Now, let's begin to address scientifically this question: what is time? So we'll put the philosophy with the philosophy now stated. We'll put that aside, and we will go to what is time scientifically. Well, let me start with a common sense type of discussion about time. Most people will say that time is a measure of change, a measure of change. And that really fits our whole common sense idea of time. And from that standpoint, many scientists, including Stephen Hawking, will say that time began at the instant of the Big Bang. Right? So, because that is the first measure of change. And actually, a number of scientists, including myself, do not believe that. But it's a valid school of thought that time began with the Big Bang. And but a number of scientists say no, that's not quite correct. When we say time is a measure of change, that's fine for our everyday life. But let's take an example where there is no change. Suppose there is no change. And I'm going to give you an example like that right now. Suppose we had an atom, a proton, with an electron running around it. This is an electron. And the proton is positive. And this is the hydrogen atom. And the picture I've drawn is the Bohr picture of the atom. It's like a planetary system. And this is not, this is more classical than it is current theory. However, the picture is easy to understand. And suppose I froze this atom, froze it to absolute zero. Well, if I did that, I'd be violating some of the laws of physics. Let's talk about that. I'd be violating, first, the laws of thermodynamics that say you cannot freeze anything to absolute zero. And the second law I'd be violating is the Heisenberg uncertainty principle that says you cannot know the position of an electron, the velocity and the position of an electron simultaneously. But if I froze it to absolute zero, it would be devoid of heat, and there would be no motion of the electron in the atom, so I actually would know exactly where it is, and it would be at rest. So I'm violating two laws. This is a thought experiment. And let's just imagine 1,000 years from now that we have the technology to do that. And I just want to say that all theories, like thermodynamics, like the Heisenberg uncertainty principle, are actually approximations. They are true within certain contexts. So we should understand them as being valid in those contexts, but the laws of the universe don't necessarily always correlate with what we've abstracted, written down, put in textbooks, and so on. So I'm looking at this as a hypothetical example to illustrate a point. If all motion stops, does time stop? No, because the atom still exists. And so if an observer is an eyeball, is looking at it, the observer is saying, wow, that's marvelous. We've frozen an atom at absolute zero. I have to show this to other people. And for the next 10, 20, 50 years, people are going to look at that and say, we've actually accomplished something extraordinary, and yet the atom exists. We've stopped all motion, but have we stopped time for this atom? And the answer is no, because it's still moving in time. It has to. If it didn't move in time, it would disappear when the observer was looking at it. So basically, it's still moving in time. So saying time is a measure of change, it's okay from a common sense viewpoint, but it's not strictly scientifically correct. So what is happening is this is existing, which means the atom, the hydrogen atom, is actually moving in time. Now, in the next post, I'm going to give you several examples that will talk about how time will vary based on perspective, and I will also talk about what the equations are, and it will be in the next couple of posts, what the equations are that describe existence. So thank you for joining me, and I'll see you in the next post.